Let's say Alice wanted to send a secure message to Bob. One of the ways she could do this would be to apply a key to that message, so that if the contents of the message were caught in transit, they could not be deciphered. This is something that has been used throughout history. It works pretty well. You might have even used it as a kid to apply it to your own messages. However, there are a number of shortcomings. We both need to know the key. We both need to agree on a key, and we need to make sure nobody else can decipher this key or come up with this key. Exchanging this key is also a challenge. No doubt you would have seen movies where there's some secret meeting, say at a train station, and people are exchanging envelopes, right? This is something that has always been a challenge when it comes to this approach. And if you consider the case of the secret meeting, what if the person was robbed? Worse than that, what if the key was robbed and nobody else knew? The subsequent messages would all be compromised. Now, if we were to send it through the web, the same type of scenario might occur, where we send it, say, through email, it is compromised or it is intercepted in transit, and all subsequent communications would be compromised. So in order to exchange a key, we would need an encrypted secure connection, but in order to establish a secure encrypted connection, we would need a key. So we're stuck. So we need another way. That other way is asymmetric encryption. In this case, we create key pairs that are related to one another. That is, in this case, you cannot guess B from A. However, A can decrypt something that was encrypted with B, and the other way around, B could decrypt something that was encrypted with A. More than that, one of them is meant to be private and the other one is meant to be public. So if we think about a way in which to describe it, you can think of a mailbox, which is the public address to which everybody can send messages to, such as in this case, and the only one who can decrypt those messages would be the person with the key to the mailbox, which in this case would be the private key. So if we go back to our example of Alice and Bob, and each of them have key pairs, both a private key and a public key, we could send information to Bob securely by encrypting it with his public key. Now, the public key is open to the world. It is not a secret. You can have access to Bob's and everybody else's keys. Likewise, Bob can have access to Alice's and everybody else's key. So what we can do is we can use his public key to be able to encrypt the message, send it to Bob, and Bob would be able to decrypt it using his private key. Now, the advantage of that is we do not have to do what we discussed previously, which is we do not have to agree on keys, we do not have to come up with a scheme, we do not have to share that information. So everything is out and open, which it certainly can expedite and can avoid some of the challenges that we discussed. Now, in addition to that, one of the things that must be said about the scheme is that you must protect your private key. If your private key is compromised, your security is gone. In the case of blockchain, if someone compromises your private key, they can immediately take your funds. It is not just blockchain, but it is any security mechanism that relies on private public key encryption has that weakness. Now, this is something you must protect in order for your system to be secure. It's very similar to password systems, and where the security is reliant upon the password, you must protect the password. Now, the other thing that must be said about this as well is that there's some additional properties here. If we consider that the private key is never distributed, that means that anything that is signed with the private key and the world has your public key can be proven to have only been authored by you, because nobody else has your private key but you. In this case, Alice is the only person with Alice's private key, and if she were to sign something with her private key and send it to Bob, Bob could decrypt it with Alice's public key, and be sure that nobody else had authored that message. Now, an additional layer to this might be if Alice first encrypts her message with her private key to prove to anybody else that receives it that it came from her, and then in this case, in addition to that, encrypts it with Bob's public key. That means nobody else would be able to decrypt the message but Bob, and once he decrypted it, he'd be able to decrypt the message inside of it that was encrypted by Alice's private key, which would mean this message was only for Bob. So it could only be opened by Bob, and once Bob opened it, he would be sure that it was authored by Alice because it had been signed with her private key and only she could have signed it. So public key infrastructure is one of the backbones of business today. It is the backbone of blockchain. It is a very powerful scheme that is heavily used.